have I list out all where they brought out integral in your question. Now 2020 question 6A, evaluate this integral, evaluate this integral, evaluate this integral, this and this. Now look at it, 6 marks, 4 marks. Don't forget they are big marks because the whole question is 15 marks and just this integral is 6 marks. This is 2020 question 8, 6, 4 marks. 2019, it came out in 2019 as well, 6 marks. Came out in 2019 again, 7 marks. Do you understand? Now let's solve. The first one is evaluate. This is 2020 question 6A. We want to integrate from x over x minus 1 x squared plus 4. Yes. Whenever you have something like this, especially when you have denominators like this, separate or write it as a partial fraction. Resolve into a partial fraction first. So look at what I'm going to do. This is s over s minus 1 s squared plus 4. So I have s minus 1, it will be equal to this. How you write it, a over s minus 1. That is the first thing. Then when you have s squared, see s squared plus 4. When you have s squared plus 4 like this, look at what you are going to write here. You will write bs plus c. Assuming you have s cubed, assuming it is s cubed plus 4 I have here, I would have written bs squared plus cs plus d. Do you understand? If it's s raised to power 5, I would have written bs4 plus cs3 plus ds squared plus es plus f. Do you understand? That is the principle of partial fraction. Do you get that? So this one is all over s squared plus 4. Clear the fraction. Multiply through by s minus 1 s squared plus 4. This one will be left with s. You will be left with s here because look at what I'm multiplying with. I'm multiplying with s minus 1 s squared plus 4. So multiply by s over s minus 1 s squared plus 4. So s minus 1 cancel, this one cancel, you will be left with x. If you multiply this one with this one, you will be left with s squared plus 4. So here our a s squared plus 4. Then this one bs plus c. You know that's what our here. If this one multiply this one, s squared plus 4 will cancel, I will left with x minus 1. So to get a, let me tell you something. Actually, the method I want to use to get a is called cover-up method. And what is cover-up method? To get a, I will find the area of how b and c will be 0. How b and c will be 0. That is it. And if I want to get b, I'll find a way of how a and c can be 0 if it's possible. The same thing for c. Now, look at it. S minus 1 is multiplying this one. So if this one is 0, 1 minus 1 is 0, this one will be 0. So I'll be able to get a. So I'll just say now put s minus 1 to be 0. S should be equal to 1. Anyway, you see s, put 1 inside it. So here will be 1 equal a. 1 squared is 1, 1 plus 4 plus 1 minus 1 is 0. 0 times anything is 0. So I'll be left with 1 equal 5a. So a is equal to 1 over 5. That is the answer to a. Now, what to get b and c? There's no way I can get b. How can I make a and c 0? It's not possible. Do you get that? So look at what I'm now going to do now from here. From here I have s. Open the bracket. This one will be as squared plus 4a. Open the bracket of this one. So I always time this one will be bs squared minus bs plus cs minus c. That is what I'm going to have. Bring them together coefficient wise. So s equal, this one is having s squared and s squared. I will have a plus b, factorize them. Do you understand? That's what I'm doing. This one is having x and s, factorize them. I have minus b plus c s. Then this is the constant 4a minus c plus 4a minus c. That's what I'm going to have. plus 4a minus c. So equating the coefficient is the next thing I'm going to talk about. Equating the coefficient. So the coefficient of x squared is a plus b. But it is so unfortunate that the coefficient of x squared, there is no x squared at the right hand side. The coefficient of x squared is a plus b. There is no x squared at the right hand side, so the coefficient is 0. So don't forget I've gotten a before. A is 1 over 5. So b is equal to minus a, and that's minus 1 over 5. Coefficient of x is minus b plus c, and it's equal to coefficient of x here is 1. So it's good. So to get c will be equal to 1 plus b. 1, but b is what? Minus 1 over 5. So 1 minus 5. The answer will be 4 over 5. So a is 1 over 5, b is minus 1 over 5, and c is this. So that means that this s over s minus 1 and s squared plus 4 is equal to a. A is what? 1 over 5. So I will write this with 1 over 5 x minus 1 plus b. B is minus 1 over 5. So I will write minus 1 over 5 plus a minus 1s, because it is bs, minus 1s plus c 4 over 5. The point is that this over 5 will come down here to have s squared plus 4 here. Do you understand? So that means what I want to integrate my integral from s to s minus 1 s squared plus 4 ds is equal to integral, then I have 1 over 5s minus 1 plus, then I will have this one minus s plus 4 all over 5 s squared plus 4 ds. So I'm going to integrate this now. That is the next thing I'm going to do. I'm going to integrate this, and let's see what we are going to get. Welcome back from the commercial break. Now look at what we have here. I have already simplified this to partial fraction. Separate the integral is the next thing to do. Integral 1 over 5, let me write it this way first. 1 over 5 x minus 1 dx plus, so you see what I'm doing? Separate this one, let it be alone, then this one, let it be alone. Integral from minus of s of this s squared plus 4 dx. Right? That is what we have. Good. Now look at what we have here. 1 over 5 is a constant. It can come outside the integral. I have 1 over 5 integral of 1 over x minus 1 dx plus. Now I will bring out minus 1 over 5 here, so that I will have minus 1 over 5. Or let me still bring out 1 over 5. You'll be left with minus. You'll be left with integral. You'll be having minus s plus 4, but I want to factorize minus here, so that I'll be having s minus 4. This one 5 is out already. I have s squared plus 4 dx. Now there is one law in integral. So when you have integral of, if you have a denominator, let's say f of s, and if you differentiate the denominator f prime of x, if you differentiate the denominator and you are getting what you have at the numerator, the integral is actually equal to log of the denominator plus c. That is one law of integral. This is one of the standard integrals we have. So what am I trying to say? If you differentiate x minus 1, differentiate x, you have 1. Differentiate 1, you have 0. So if I differentiate x minus 1, I have 1, and which is at the numerator. So this one will be 1 over 5 log or ln. You can write ln or log, whichever one you want to write is correct. Do you understand? Now bring out this minus here, 1 over 5. This is integral of x minus 4 over x squared plus 4. Look at what I'm going to do to this one. I have 1 over 5 log. The same thing I did here. Differentiate the denominator, I have what? 2x plus 0, which is 2x, but I have x minus 5 in the denominator. Look at what I'm going to do. I will have minus 1 over 5 integral. Look at what I will separate this one to be x over x squared plus 4 ds, then minus integral 4 over x squared plus 4 ds. You see what I have done? Oh, minus times minus will give me plus 1 over 5. This 1 over 5 is for everything, right? You know, it's like having a, look at what I've done. If I have a plus b over c, that's what I've done. It will be a over c plus b over c. So this is like a minus b, everything over c. So a over x squared plus 4, right? Minus 4, but minus times minus gives plus. So 1 over 5, 4 over x squared plus. So that is what I have here. What will be the next thing now to do? To round off this question, this will be equal to 1 over 5 log of x minus 1. Now, if you differentiate the denominator here, you have 2x, but I have x here. So what am I going to do? I will multiply and divide by 2. That's all I want to do. I will have minus 1 over 5 times 1 over 2. You see what I have done? Then 2x will be here, all over x squared plus 4 ds. This 1 over 2 can come out because it's a constant, but if you enter back 1 over 2 times 2, 2 cancel 2, you will be back to this question. So I have not done anything. So you get my point, I have not changed anything. So this is plus, this 4 can come outside, 4 over 5, then you are left with 1 over x squared. And mind you, this 4 is also 2 squared. Yes. Now look at it to round up this question. This is equal to 1 over 5 log of x minus 1, right? This is what? Minus 1 over 10. If we differentiate this down, you get the up one. So this one will also be log of x squared plus 4. Now plus 4 over 5. It remains this third integral 1 over x squared plus 2 squared. Yes, so now I'm going to recall another standard integral for you, which I'm going to apply to solve this one. You need to know something here, especially if you don't know before. If you have integral of 1 over x squared plus a squared ds, the answer, whenever you have x squared plus a squared, so in reality I have 1 over x squared plus 2 squared, that means my a is 2. The answer will be 1 over a, this a here, arctan of x over a. That is what you are going to have. Do you understand? So that means that this one, integral of 1 over x squared plus 2 squared ds, it will be equal to 1 over 2 arctan of x over 2. Do you understand? So that is what you have. Please, you have to note this definite integral. It has proof actually, but you know, you are preparing. This is final preparation for your exam. So you need to know how to do things, and you can see where we are coming from. Number one, the first thing you need to do is to separate into partial fraction, and it's just 6 months. Don't let it waste your time too much. Separate into partial fraction. That's the first thing. Then you will now be splitting the way I'm splitting, as you can see. So at the end of the day, the final answer to the integral, that is integral of x over x minus 1 x squared plus 4 ds, will now be equal to all these things that I have here. 1 over 5 log x minus 1, right? Then minus 1 over 10 log means lean, though. The base is e, lean or log to base e, x squared plus 4, then plus, you know, I have 4 over 5. 4 over 5 times 1 over 2, that will give me 2 over 5. So this one will give me plus 2 over 5 arctan of x over 2. Don't forget the last thing, the constant. I am done integrating that. Please, you have to check the video again so that you can understand, especially if you don't know how to solve this type of question. If you see this type of question in the exam, please, please, you have to get it. You must get it. Do you understand? Please. Now let's go to the next question. So what do we have here? The next question says is 2019 question 3B. This one is 4 marks. You say that integrate s plus 1 over s squared minus 6s plus 8. Right? Now, whenever you see question like this, try to factorize the denominator, whether it can be factorizable. If you know how to, you should be able to do quadratic equation. But if you don't know, use calculator. I've showed you, like you would have seen my video where I use calculator to solve quadratic equation. I call it quadratic. Yeah, it's quadratic now. So now quadratic equation like this. Now s squared minus 6s plus 8. If you solve this one, you will get s to be 4 and 2. Do you get my point? You will get s to be equal to 4 and 2. So that means to factorize this one would have been s minus 4, s minus 2. This is the factorization of this one. Do you understand? So what am I trying to say? What I'm trying to say is that this will be equal to the integral of s plus 1 over this one I have at the denominator will be what? S minus 4, s minus 2 ds. So the same way, the same approach you just finished there. Whenever you see something like this, separate into partial fraction and solve. So now resolve s plus 1 over s minus 4, s minus 2 into partial fraction. That's what you need to do. You have to be able to resolve it into partial fraction. How do you do that? You have s plus 1 over s minus 4, s minus 2, then it will be equal to a, since this is a over s minus 4 plus b over s minus 2. So clear fraction. When I say clear fraction, it means you multiply all this one by s plus 4, s minus 2. So this one you just be left with s plus 1 here. You'll be left with the numerator here. Let me just tell you the summary of what you'll be left with. S plus 1 here is equal to a, denominator of this one, s minus 2 plus b, the denominator of this one. Assuming there is a c, maybe plus c over something, a would have the denominator of b and c. Do you understand? Or I've explained when I was doing this first one how they are cutting themselves. That clear fraction, the LCM will be s multiplied through by s minus 1 and s minus 2. This is what you will get. Now to get a, b must be 0, and what is beside the s minus 4? Make it 0. Do you understand? Once this one can be 0, you can get a. So what do I have? Put s minus 4 to be 0. So s will be equal to what? 4. So put s to be 4. Anywhere you see s, put 4. So that means here I will have 4 plus 1. 4 plus 1 is 5 equal a, open bracket, 4 minus 2. Or let me write 4 minus 2. Then this one is 0. So 5 equal to a. Divide both sides by 2. A is 5 over 2. That is the answer we have for this question. Now to get b, a must be 0. So s minus 2 must be 0. So again put s minus 2 to be 0. So s is equal to 2. Anyway, you see s put 2. So at the end of the day, again, I have 2 plus 1, 3 is equal to 2 minus 2 is 0. So I've left 2 minus 4. That is minus 2b. So b is equal to minus 3 over 2. So a is 5 over 2. B is minus 3 over 2. So at the end of the day, so I have what? So please pay attention to the techniques. At the end of the day, it means that s plus 1 all over s minus 4, s minus 2 equal a. A is 5 over 2. That's 5. I told you, you can see the way I did it earlier. The denominator of this one can come down as well. S minus 4, right? Plus b. But b is minus 3. So minus 3 over 2. S minus 2. That is the answer to the what? Partial fraction. So that is this integral of s plus 1 over s squared minus 6s plus 8 ds is equal to integral. Then I have 5 over 2. Right? Are you getting what I'm doing? S minus 4. That's what it becomes because you are the same. Minus 3 all over 2. s minus 2 dx. That is what I have. So at the end of the day, this one will become 5 over 2 integral of 1 over x minus 4 ds. Separate it. That's what I'm doing. So I'm separating it now. This is 5 over 2. Let it come outside. Then I have integral. Nothing will be left here. 5 over 2 is a constant. So I have 1 over x minus 4. Then minus 3 over 2. 1 over x minus 2 ds. That is what I'm going to have as well. So this is equal to 5 over 2. Differentiate what is down. Differentiate s, the answer is 1. Differentiate minus 4, the answer is 0. So this one will also be log s minus 4 minus 3 over 2. The same thing happens here as well. Log s minus 2 plus c. And that's all. That's all. So let's go to the next question. Please, if you have not subscribed, subscribe to this YouTube channel. I beg of you. And if you have friends that are also doing this course or that will be of help to him or her, please don't hesitate to let him or her know. Thank you very much. 2019 question 4B. 2019 question 4B. Now this one you can use calculator. Yeah, if you have this calculator, you can actually use it. Don't worry, I'll show you how to use the calculator. But you can look at it. Wait, go and look for integral. Put 0 to pi over 2, or pi is 180. 180 divided by 2 is 90. Or you will see pi also on the calculator if you are very conversant with the calculator. This is a theory question. So assuming it's an objective question, use calculator direct and get your answer and leave there. That's number 1. Number 2, you can use calculator to confirm your answer in this theory. Do you get my point? But then let's solve. You see this one and this one. Let me tell you something now. Let me tell you what you need to know. You can use calculator to solve any integral that has bound. Do you understand? Any integral that has bound, maybe 0 to something, 0 to something, so you can use calculator to solve it. Do you understand? So please take note of that. And don't worry, by the time I'm doing the tutorial on how to use calculator to solve integrals, you will see it. You will see how it is being done clearly. Even if you don't understand it very clearly now, but you must know how to show working so that you don't drop points. All this one I've been doing so far, if you have been writing in this way, then your mark is sure, like your full marks. Let's continue. Okay. Now I have an integral from 0 to pi over 2 of cos s ds. So what do I have there? Now, what happened is that, what will you differentiate that will give you cos? What will you differentiate that will give you cos? The answer is sine. If y equals sine s, when you differentiate it, you will get what? Cos s. Do you get my point? You will get cos s. So that is for this. Integral is opposite of differentiation. So what will you differentiate that will give you cos? You know that is sine. Or normally integral of course is sine. So the answer will now be equal to sine s. Then put the bound. Bound is from 0 to pi over 2. So whenever you have bound, you don't need to be writing plus constant. Do you get my point? You don't need to be writing plus c. From 0 to pi over 2. So this one will now be sine pi over 2 minus sine 0. Sine pi over 2 sine 90. Press calculator. Sine 90 is 1. 1 minus sine 0. Sine 0 is 0. 1 minus 0 is 1. So the answer to this question is 1. 3 marks. Imagine. II. Integral from 0 to pi over 4. Sec square s plus tan square ds. So how do we go about this one? You have to, you see that differential something I wrote for you, it has to be, you have to be able to remember it, because if you can remember it, it will give you hint. Because you know that if y equal tan s, right? If y equal tan s, if you differentiate tan s, you have sec square s, and sec square s is here. And don't forget, we come from the identity. Look at how I'm going to solve it now. You have to know identity. Even if you are doing trigonometry, integral, or differentiation, or limit, identity is very important. They will just be using identity anyhow up and down. So now, actually, we call That's what? 1 plus tan square s is equal to what? Sec square s. Make tan square s the subject, so that means that tan square is equal to sec square s minus 1. That is what I'm going to have, sec square s minus 1. So what will happen to that? So what will happen to that is that this one will now become the integral from 0 to pi over 4. I have sec square s plus this one will have tan square s is sec square s minus 1. Sec square s minus 1. Integral from 0 to pi over 4. Sec square s plus sec square s is what? 2 sec square s minus 1 ds, right? So this is 2. If you integrate sec square s, it means what do you differentiate to get sec square s? The answer is tan. So 2 tan s minus 1. If you integrate 1, the answer is s, because if you differentiate s, the answer is 1. Maybe you are thinking, how is s always 1? This is s raised to power 1. I told you to differentiate is the power, then it comes down. That's 1s, then 1 minus 1. 1 minus 1 is 0. Anything raised to power 0 is 1. 1 times 1, 1. Do you get that? That's the differentiation. So if you integrate 1, the answer is s. So put the boundary from 0 to pi over 4. So this is pi over 4 is 45. Pi is 180. Pi divided by 180 divided by 4 is 45. So this is 2 tan pi over 4 minus s. Anywhere it's here, that's where you put it to. Then minus 2 tan 0 minus 0. Tan pi over 4, that's 45. Tan 45 is 1. So this is 2 times 1, 2, minus pi over 4, right? 2 tan 0. Tan 0 is 0. 0 minus 0 is 0. So the answer is just. So the answer is exactly this. Thank you very much. And that's all. So let me write out the next question. Do you get my point? Stay tuned. Yes, so now let's continue. This is another question. This is for 2020 question 8A, and it has the total marks here is 9, and this is 8B, 2 marks. Now, a particle P moves in a straight line that passes through the origin O. The velocity of P at time t seconds is v meter per second, where v is equal to this. So I'm giving velocity to be equal to 20t minus t cubed, right? At time t equal to 0, the particle is at rest at a point whose displacement from O is 36 meters. And I say find an expression for the displacement of P from O in terms of t. Now, I wrote something here. When you have displacement, another name they normally call this displacement is position. You get my point? If you are given displacement or position, and they say you should find velocity, differentiate it. Do you understand? If you are given velocity and they say you should find acceleration, differentiate the velocity, you get acceleration. Do you understand my point? Do you get that? Now, that is what's happening here. So, if they give you displacement or position and they say you should find acceleration, you will differentiate 2 times. Do you understand? Don't forget, velocity is displacement over time. So, differentiate the displacement with respect to time, that's velocity. Differentiate velocity with respect to time, that's acceleration. Do you get that? But now, if you are given acceleration and they say you should find velocity, integrate, opposite. Opposite of differentiation is integration. So, you will integrate. If you are given velocity and you are told to find displacement, you will also integrate. Do you get that? So, whichever one you are given, you have to integrate. Whenever it's coming this way, you have to integrate. Do you get that? Now, in this case now, I'm giving velocity, they want me to find displacement. So, I'm going to integrate. So, integrate with respect to t, v, integrate v with respect to t, and this one 20t minus t cubed dt, right? Integrate it. This one will become displacement, position, s. Do you get that? This one will become s, position or displacement, anyone you want to call it. Then differentiate, integrate this one. No, let me give you one rule of integration. when you have to integrate s raised to power n ds, you know, in differentiation, I told you that the power will come down, write the equation, then subtract 1 from the power. But in integration, look at what will happen. Go to the power, you first go to the power, add 1. Add 1 to the power, then divide by the power. The power is s raised to power n, add 1 to it. Write the equation, Sn plus 1 for the power, then all over everything on that power. Everything here, divide it with it. Plus c. That is what, that's a standard integral. That's how we integrate function of n. So this one will become, this is 20. This is 3 raised to power 1, right? 1 plus 1 will give me 2. So divided by the whole power 2, this is minus 3 raised to power 3 plus 1 all over 3 plus 1. Don't forget plus 1 constant. S equal, this is 10t squared minus 3 raised to power 4 over 4 plus c. This is the displacement, but you have to find c. How do you get c? So I have told you already, at time t equal to 0, the particle is at rest from a point. Once the displacement from 0 is 36 meters from the origin, that is from the starting point, origin O, is 36 meters. So that means to get this c, when t is 0, s is 36 meters. So put it there. So I will have this one will be 36 equal, this one will be 0 minus 0 plus c. So that means c is 36. Do you understand? So that means the displacement they want me to find, or the displacement they want me to find in this I, that is 4 marks, is 10t squared minus 3 raised to power 4 over 4 plus 36. And that's the answer. Do you get that? I'm done. So now for the second one, they say find the displacement from O when t is 4. That means this second one, just put it to be 4 there. That's what they are asking you to do. So I s equal, 10t squared minus 3 raised to power 4 over 4 plus 36. Now s equal, they say t is 4. It has been given. So this is 10 open brackets 4 squared minus 4 raised to power 4 over 4 plus 36. 4 squared is 16. 16 times 10, 160. 4 raised to power 4 is 4 raised to power 4 divided by 4 is 4 raised to power 3, which is 64 minus 64 plus 36. 160 minus 64 will give me 90 what? 160 minus 64 will give me 98. No, 96. Why? Because 160 minus 60 will give me 100. 100 minus 4 will give me 96. 96 minus 36 will give me 60. 96 minus 36 will give me 60. Or whichever one, let us use calculator to be on the safer side. When you are in the example, use calculator. 160 minus 64 plus 36. So actually, I have 132 actually. I was subtracting. I have 132 meter. That is the answer. I was subtracting 36 again. So now, the next one, I. Find the value of t for which the particle is at 0. So they want me to find t when s is 0. So find the particle when s is 0. Look at what I am going to do now. So we want to solve s equal 10t squared, right? Minus 3 raised to power 4 over 4. That is what we have. So put it to be 0. That means 0 is equal to 10t squared minus 3 raised to power 4 over 4 plus 36. Multiply 2 by 4 first. 0 equal 40 t squared minus 3 raised to power 4 plus 36 times 4. 36 times 4, that's 72 times 2, 144. So the answer is 144. So plus 144 actually. Bring everything to the other side. You have t raised to power 4 minus 40t squared minus 144. You can try to solve this on calculator, or you say let y be equal to t squared. So that means t raised to power 4 will be y squared. So this one will now be y squared minus 40y minus 144 equal to 0. So you can use, this is a quadratic equation, you can solve it anyhow you like it, any method you know. Do you understand my point? So you can use formula method if factorization is not forthcoming. You can solve it. So basically, okay, let's use formula method. So the answer will be minus b plus or minus square root of b squared minus 4ac all over 2a. So y will be equal to a is 1, b is minus 46, 144. So this one will become 40 plus or minus square root of minus 40 squared, that is 1600 plus 4, a is 1, c is 144. You know, minus 4 times 1 times minus 144. That's why I put plus there. Basically, we are doing quadratic equation. So you get my point. All over 2. So y equal 40 plus or minus square root of what? 1600. So use calculator from here. I don't want to don't complicate issues. Like you can use calculator to solve directly. I don't want to waste time. So this one I have 1 minus 40 minus 144. So s is 20. So I got some answer here. I got s is 20 plus 4 root 34, which is actually equal to 43.32, right? 43.32. Then the second one, of course, you know, you will get to answer. Y is still also 20 minus 4 root 34, which will also give me minus 3.238. Now recall that y equals t squared. So recall that t squared equal y. So that means t will be equal to plus or minus square root of y. So you can have plus or minus of a negative number, you get a complex answer. So you can't use this one. So we only use 43.32. So t will be equal to plus or minus square root of 43.32 to square root of 43.32. So the answer is plus or minus 6.58. 6.58 seconds. But don't forget, time cannot be what? Negative. So the answer to this one is time equals 6.58 seconds. That's how to solve this. Now the second one, this 2020B, this big question. What we are going to do to the big question is that question 8b. They say limit as s goes to 0 of 3x cubed plus 5x minus 1 over 4x cubed plus 2x plus 6. Now, I'm going to write another question now. Limit as s goes to infinity of 3x cubed plus 5x minus 1, 4x cubed plus 2x plus 6. Now, what happened here is that you need to shine your eye. This is limit as s goes to 0. It is when limit this is a bit. It is when limit as s goes to infinity. That's why you will be dividing by the highest power. You divide both numerator and denominator by the highest power. But this one, put the value straight. Don't forget, in limits, let me tell you, what you are giving, when you are told to find limit, put the value straight. It is when you get 0 over 0 or infinity over infinity. That is when you have to think of maybe hospital rule or to factorize or to find a way out. Do you understand? But what you are giving is different from these two answers, from this indeterminate form. Please, that is the answer. Do you understand? So this question that they are asking now, I will just put 0. I'll put 0 there. Put 0 straight. This is 0 plus 0 minus 1. So my answer will be minus 1, 0, 0, 6. Minus 1 over 6. That is the answer. But assuming it is limit as s goes to infinity, I will divide through by the highest power. And if you divide through by the highest power, this you see how limit as s goes to infinity here. You now have 3 plus 5 over s squared minus 1 over s cubed all over 4 plus 2 over s squared plus 6 over s cubed. That kind of thing. So the answer will now be just 3 over 4. Please take note of that. Don't make that mistake. Do you understand? Thank you very much. Next question. So now let's continue. So you can see this is 2019 question 3A. A vehicle starts from rest and the velocity is measured every 8 seconds as follows. They have given us the table. The distance traveled in 8 seconds is given by integral from 0 to 8 of v to t. Estimate this distance using Simpson's rule. They want me to use Simpson's rule. The same thing in 2018 question 3. It also came out in 2018 question 3 that employs Simpson's rule to approximate integral from 0 to pi over 2 of cos half x ds at n equals 6. Do you understand? Now look at this one. Calculate the area close area under the curve. Then sketch the graph of this. They want me to state this. Now, for the first two questions, you know, they asked us to use Simpson's rule. Now I need to tell you some things. You know, we can integrate. We can do normal integral. That one is called analytical way of integrating. There is the numerical way of integrating. Do you understand? So one of it is trapezoidal rule or trapezium rule. What does that mean? See, integral, if they say you should integrate, if they say, see this one now, we want to integrate it using what? Simpson's rule, right? Number 2, using Simpson's rule. They can bring another question and say, use trapezium rule. Do you understand? That's why I'm giving you the formula now, and you will see how it is being used. Do you understand? When you have integral from a to b of f of s ds, and you want to use trapezium rule, you must have 1 over 2h in front. What is h? You know, h must the integral must be bounded. Do you understand? Must have bound, like something must have lower and upper bound. So h is equal to b minus a all over n. N is how many, like the number of spreading they have here. Do you understand what I mean by spreading? Like you can see spread. That's what it means. Like, do you understand? Like n is, you can see they give me n to be 6 here. You will be given, or if you are giving, it's either you are giving table, or you are giving this. Or at times, let me tell you something, they will give you h. You see that I will now find the n yourself. N will be equal to b minus a over h. Do you understand my point? Do you get that? Now, so that is one thing. So you will be able to get this h. It will not be 1 over 2h. Then this y naught, see, f of c, y is f of s. So do you understand? So if you see y naught is f of s naught. What, like in this case now, this is like my s. Do you understand? This is my y. So this is s naught, y naught, s1, y1, s2, y2, s3, y3, s4, y4, like that. Do you understand? This second example, you are not given table at all. So you are the one that will draw the table by yourself. Do you understand? So pay attention to what I'm saying now. For trapezoidal rule, you have 1 over 2h, then you have y naught plus yn plus 2. Do you understand? The first one and the last one first, y naught plus yn, then 2 times every other thing that is at the middle. Do you understand? That is for trapezoidal rule. Now for Simpson's rule, actually, in reality, there are 2 Simpson's rule. We have Simpson's 1/3 rule and we have Simpson's 3/8 rule. This Simpson's 1/3 rule, the n that you must be given must be a multiple of 2. Do you understand? This n must be a multiple of 2. This Simpson's 3/8 rule, it must be a multiple of 3. Do you understand? That is Simpson's 1/3 and I did not write it. See, I generalized this one because I wrote from y naught to yn. This one is because I have 8 something here, like that's why I just wrote for Simpson's 1/3 rule. Now they said employ Simpson's rule. When you are told to use Simpson's rule, what they want you to use is Simpson's 1/3 rule. Do you understand? So now, what is Simpson's one? Number 1 is 1/3, 1 over 3h. Do you understand? See, 3 over 8h. For trapezoidal rule, 1 over 2h. Do you understand? But 1/3, 1 over 3h. Then you have y naught, the first and the last. Do you understand? Let me tell you the logic behind 1/3 rule. You know, I've told you the logic here. You must add the first and the last, right? Then 2 times every other thing at the middle. Do you understand? But don't worry, by the time you apply Simpson's rule on this one, you will understand better. Now, for Simpson's 1/3 rule, the same thing. 1 over 3h first. The first one, that is y naught and yn, that the first and the last, y naught and yn, plus 2. All the even numbers, like all the even numbers between them, like y2, y4, y6. Don't write yn, y8 is already here. Do you understand? The last number will be here. So then plus 2, y0, y2, y4, y6, y8, y10. Assuming I have y to y20. It would have been y0 plus y20 then plus 2 open bracket y2 y4 till I get to y18 and stop there. Then plus 4. This 4 will now be for odd numbers for 4 y1 y3 y5 y7. Do you understand? You can't write y9 because it actually stops at y8. Do you understand? So if assuming this one stop, assuming I have y0 to y20, since 38 would have been written as 1 over 3h y0 plus y20 plus 2 open bracket y2 y4 y6 y8 till you get to y18 even numbers plus 4. Then you now write all numbers out. You start from y1 y3 y5 y7 till you get to y19. Do you understand? That is Simpson's 132. Since 38 you can see it, I just use 6. So the same thing happens to Simpson 382, but look at the approach of this one. 3 over 8h. That is what will be outside. Open bracket y0 plus yn. That is the first and last. No, I'm just using 6 here. I'm just using 6 as an example. y0 plus yn. That is the first and the last. Then I told you this one must be a multiple of 3. Then the other remaining multiple of 3 we have 2. Do you understand? Assuming I told you this one must be a multiple of 3. Assuming I have y0 to y12. Assuming I have y0 to y12 now. Simpson's 382 would have been what? Let me show you what it would have been. It would have been 3 over 8h. You first do y0 plus, I know I have y0 to y12. To y12, that is the first thing, plus 2. These two, every multiple of 3. Look at it, y3, y6, y9. The next one is 12, but it's already here, so you can't write it, so you stop. Then every other numbers, 3, you now do y1 plus y2 plus, don't write y3, it's already here. You now write y4, y5. You'll be skipping all the ones that are already here. Do you understand? That is Simpson's 382. But now let's come to the question we have here today. So they have helped us to, they have given us this value. So what do I need to get? What I need to get now is what? I need h. H is b minus a over n. What is b? B is, see, this is a to b. Integral from 0 to 8. Integral from 0 to 8. A is 0, b is 8. So this one would have been 8 minus 0 all over n. See, you start counting from 0. Actually, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Start counting from 0 to 8. So that means n is 8. Or they have even told you every seconds for 8 seconds. Do you understand? N is 8. 8 minus 0, 8. 8 divided by 8, 1. So that integral from 0 to 8 of v dt is equal to 1 over 3h. That is 1 over 3 times h, but h is 1. 1 over 3 times 1 is still 1. Open bracket. Why not? Why not? See, this is, I told you before, this is s. This is your y. Why not? This is y not. y1, y2, y3, y4, y5, y6, y7, y8. Do you understand? So y not is 0. Right? 0. Plus y8. y8 is 9.4. 9.4. Then plus what? 2. Please take note of this formula. It's easy to remember the way I've explained it to you. Do you understand? If you don't remember, look at the video again. Like, watch the video again. So this is plus 2. y2. See, let me help you. Let me state it out clearly. In fact, it's even obvious. So this is y2. I need y2, y4, y6. Do you understand? So plus 2 open bracket y2. y2 is 1.0. Plus y4. y4 is 2.9. Do you understand? Plus y6. y6 is 6.2. Then plus, now I have plus 4 open bracket y1. y1 is 0.4 plus y3. y3 is 1.7 plus y5. y5 is 4.1 plus y7. y7 is 8.0. Then you close it. So integral from 0 to 8 of v dt is 1 over 3. Open the bracket. 0 plus 9.4 is 9.4 plus all these ones. You actually need calculator to solve all these ones. So this one would have been 1 plus 2.9 plus 6.2 times 2. You use calculator to solve this one. So this is 20.2. That is what I got. 20.2 plus then all these ones 0.4 plus 1.7 plus 4.1 plus 8.0 multiplied by 4. So this is 56.8. So add everything, then divide by 3. 56.8 plus 20.2 plus 9.4 divided by 3. So the answer I got is 28.8. So the answer there, the distance traveled in 8 seconds is given by this. So what is the estimate the distance in Simpson's rule? So the distance is 28.8 meters by Simpson's what? 1/3 rule. But when they say use Simpson's rule, what they just mean that use Simpson's 1/3 rule. The same question, the next question, 3C. Now look at 3C. This is 3C. Employ Simpson's rule to approximate. Right? Employ Simpson's rule to approximate. Even apart from this one, I recall something now. Apart from getting h to be 1, h is actually the steps. It's called steps. That is, what are they using to jump? Like the difference between the difference between this one and this one is 1. So that means h is 1. Do you get that? But leave that one. Let's continue what we are doing here. Integral from 0 to pi over 2 of cos r s ds at n equal what? 6. Do you understand? Now, this is your f of x. F of x here is square root of cos s. The cos raised to power 1/2 means square root. Now, find your h. Don't forget, they did not give you table here. You will draw the table by yourself. Find your h. H is b minus a over n. That is pi over 2 minus 6. B is, this is lower bound. Lower bound is a, upper bound is b. So pi over 2 minus 0 over n. N is 6. So at the end of the day, this one will become pi over 12. That is what that one will become. Do you understand? So this will be the step. You will understand what I mean by step now. Don't worry. Look at the table I'm going to draw. So I'm done with this one. So this is the table. So you will have x here, then y. Y is f of x. Y is f of x equals this. You get my point. So f of x or y. Or maybe I should write y so that you will get it. Now you will start. See what's happening here is that you must start from 0 and stop at pi over 2. And your end must be 6. That if you count the number of if you count starting from 0, you must start from 0. Don't forget this one. I say starting from 0. If you count down, you get 8. Starting from 0, if you count down, you must get what? 6. Do you get my point? So maybe I should even include n. I should even include it so that you will see what I'm trying to say, like so that you will know. Like let me put n here. So 0, 1. This is my counter. This n is my counter. That is n is 0, 1, 2, 3, 4, 5, 6. You get my point now. So what is x? X is this value between 0 and pi over 8. If you see the x here, it is between 0 and 8. You can see start from 0 and end at 8, which I've rubbed off, right? The same thing too. This one will start from 0 and it must end at pi over 2. What will now be the step? The step is this h. That is what we call step. That is, you will be adding pi over 8 to it. Add pi over 8. Is 0 plus pi over 12 rather. Is 0 plus pi over 12. Pi over 12. Is 0 plus pi over 12 plus pi over 12. That's 2 pi over 12. 2 pi over 12 is 2 can go. Pi over 6. Meanwhile, 2 pi over 12 plus pi over 12, 3 pi over 12. That is pi over 4. Write it. 3 pi over 12. That's what you do. This is 0. Add pi over 12. Pi over 12. Because that is it. That is the step. That is the gap between each of them. Do you understand? So now, pi over 12 plus pi over 12, 2 pi over 12, which is pi over 6. 2 pi over 12 plus pi over 12, 3 pi over 12, which is pi over 4. 3 pi over 12 plus pi over 12, that is 4 pi over 12, which is pi over 3. Then 4 pi over 12 plus pi over 12, that is 5 pi. 4 pi over 12 plus, that's 5 pi over 12. So this one is 5 pi over 12. 5 pi over 12 plus pi over 12, that will give me 6 pi over 12. 6 here 1, 6 in 2. Do you understand? Or you press 6 pi over 12 on your calculator, you get pi over 2. So you can see that I started from 0 and I end at this. Now what will now be the y? Y will now be square root of cos s. Y is f of x, which is the square root of cos s. What does that mean? How do you get this place? This one is s, so when s is 0, that is cos 0. Cos 0 is what? 1. So square root of 1, you see, this is how you get the function. This is, what is inside the integral is your function. You see, they did not give me function here, that's how they have to give me table. Assuming they have given me the function of v, like what it is, I will be the one to find the table by myself. So all these values I have here, I will be using it to get y. So my y naught will now be when s is 0, put it. When s is pi over 2, that will be my y1. Do you understand? So put it inside this one. You need calculator, you use cos 0. No, this is 0 now. Cos 0 is 1. Square root of 1. 1. Pi over 12, that is 180 divided by 12. 180 divided by 12 is 15. So the next one, for this one now, cos 15, square root of cos 15. Square root of cos 15. The answer is 0.9828. So let's try to 4 decimal place. It's 0.9828. So that's what you'll be pressing. Now, pi over 6, that is 30. Pi over 6 is what? 180 divided by 6. That is 30. Cos 30 is 3 over 2. Or you just do square root of cos 30. Just write square root of cos 30. You will get 0.9306. Now pi over 4. Pi over 4 is 45. Square root of cos 45. That's what you'll be pressing on. Is 0.8409. Pi over 3 is what? Pi over 3 is 180 divided by 3, 60. Square root of cos 60 is 0.7071. 0.7071. Now, the next one, 5 pi over 12. 5 pi over 12 is what? 5 pi over 12 is 75, right? So square root of, you see, this is what I'm using to get this value. Square root, you don't be putting x. When x is pi over 3, you'll be putting square root of cos 75. 5 pi over 3 is 75. Pi over 3, that's 75. Square root of cos 75. Square root of cos 75, I have 0.585087. I hope you are also pressing your calculator, so and I hope we are getting the same values. If you are not getting these values, you will have to probably you will have to contact me, or maybe your calculator is not something is wrong somewhere. That's my point. Now the last one, pi over 2. Pi over 2, that is 180 divided by 2, 90. Cos 90 is 0, right? Square root of 0 is 0. So this one will be 0. That's what we have. Now, yeah, almost rounding off. Now, what will be my Simpson's 38 rule? You know, integral from 0 to pi over 2 of cos 1 over 2s. So the point is, well, don't look at this formula. Guess, say after me, like, look at it again. Simpson's 38, 1/3 rule, 1/3, 1 over 3. Guess what it will be? 1 over 3h, open bracket. Then you do what? Y naught plus, no, this one is y naught to y6. So the y naught to y6 plus what? 2 even numbers. Y2 plus y4. Don't write y6, so y6 is already here. Plus then 4 odd numbers. Y1, y3, y5. That is what you are going to have. That is Simpson's 1/3 rule that they ask you to use. Now to finish this game, h is what? Pi over 12. So 1 over 3 times pi over 12. That is pi over 36. Right? Open bracket. You will now be adding y naught is 1. Y6 is 0. Do you see what I'm doing? You see, n is 0. This is y naught, y1, y2, y3, y4, y5, y6 plus 2. Y2 plus y4. Y2 is 0.9306 plus y4 is 0.7071 plus 4. Open bracket. Y1 is 0.9828 plus y3 is 0.8409 plus y5 is 0.5087. So now this is pi over 36. 1 plus 0 is 1 plus 2. Now you use calculator here. I told you earlier that calculator is most of the work here. Is 0.9306 plus 0.7071, right? Multiplied by 2. So the answer is 3.2754. 3.2754 plus, now the next one is 0.9828 plus 0.8409 plus 0.5087. So multiply by 4. The answer is 9.3296. Now add all these ones together. 1 plus 3.2754 plus 9.3296. So I get an answer divided by 36 divided by 36. Now what am I trying to do? This is 0.33779 pi. If you don't know what pi is, don't go and say pi is 180. It is when it is inside angle. Like, it is when it is inside the angle you say pi is 180. Do you understand? If you don't know what pi is, just leave your answer in terms of pi, or better still, pi is 3.142. Or the pi on your calculator, just press 0.33779 times pi. If you press shift and the button before answer, you will see pi there. So the answer will just be 1.1872. That will be the answer. Now you can confirm whether you are correct or wrong using calculator. I will show you in another video how to use calculator to check this. You will just press this. I told you can easily press this one, this integral, and the answer this calculator must give you must not be too far from this. Do you understand? You use pi in that calculator, that pi you have there, you use it like that on it. It must not be too far. If it's far from it, you have done rubbish with confidence. Do you get my point? Thank you. So now I'm done with triposodal Simpson 2. Now, the next question to answer now is so 2018 question 4D. Now, calculate the area enclosed between the curves. You know, you have the first curve y equal 5x minus s squared minus 4, then the second one y equal x minus 1. The first thing to do is that equate the two of them. You know, y is equal to this, y is equal to this. Equate it and solve the resulting equation you have. You must get the boundary first. You are going to integrate. When they say area under the curve, you are using integration, but you need to get the bound first. So this means that I have 5x minus x squared minus 4 equal x minus 1. Bring all these ones to the other side. Bring everything here so that this one will remain 0. S squared, you know, this is minus s squared. When it comes here, it becomes plus. This is 5s minus 5 plus x. That is minus 4s. This is minus 4. This is plus 4 minus 1. That's plus 3. Let me write it well. I have x squared minus 4x plus 3 equals to 0. So you can solve this equation. This is x minus 3, x minus 1 equals 0. So s is equal to 3 or 1. So So that is my boundary. Now, the second thing you need to note is that which one is bigger? Which one is bigger? How will you know the one that is bigger? This one is a straight line actually. Do you understand? This one is a straight line. This one is bigger than this one actually, and this interval actually is bigger. But how will you know? That is the question. So the thing is that since you have look at it, this is a quadratic equation, right? But the power of x squared is negative. So that means, let me show you, let me just show you briefly. That means the quadratic, there are two ways a quadratic equation look. The first one is like this. That is when the coefficient of x squared is greater than 0. Do you understand my point? See this one now. This is if I write this one, this is minus x squared plus 5x minus 4. You see, there's this one. The coefficient of x squared is negative. Do you understand? When the coefficient is positive, this is the graph you are going to have. Do you understand? When the coefficient is negative, this is what you are going to have. Do you understand? This is how the graph will look like when a is less than 0 from as squared plus bs plus c. This is quadratic equation. If the a is less than 0, this is what you are going to have. And this is the straight line with gradient 1. So the straight line will look like this. You get, so you can see between 1 and 3. So when x is 1, what do we have? When x is 1, y is 0. This is when x is 1, y is 0, right? When x is 3, y is 2. So when x is 3, maybe y is 2 somewhere here. Do you understand? Do you get that? So now look at what we have now. What do we do? Integrate. Let me tell you one secret you need to know. If you integrate and you get a negative value, then that means you have put the bigger one, you have put the smaller one before the bigger one. So, but in essence, let us integrate. Let me show you what we are talking about. So, my point is, this is y1, this is y2. So, to find area under the curve, you have integral from, this is the boundary between 1 and 3. You now do y1 minus y2 ds. That's what you will do. If you do this one and you get a negative answer, that means what you are supposed to do is y2 minus y1. Do you get that? Do you get that? Or to be on the safer side, you put in absolute value, but then let's do y1 minus y1 minus y2. So this is integral between 1 and 3. What is y1? y1 is this 5x minus x squared, right? Minus 4 minus y2. y2 is x minus 1. That's how to find the area under the curve. So this is integral 1 to 3 of, so this is 5x minus x squared minus 4 minus x plus 1 dx, right? Right? So look at what will happen here. This one will now be integral between 1 to 3. I have minus x squared here. 5s minus s, 4s plus 4s. What do I have again? Minus 4 plus 1, minus 3. So integrating, we will have minus s cubed over 3 plus 2s squared, actually minus 3s, between 1 and 3. So look at what will happen. Put 3 here, this is minus 3 cubed, 27 divided by 3, that's 9, right? Plus 3 squared is 4, and 3 squared is 9, 9 times 4, 9 times 2, 18. minus 9. Right? That is what I'm going to have. Then minus, put 1, minus 1, this is minus 1 over 3 plus 2 minus 3. That's what we are going to have here as well. Now, what will happen here? Minus 9 minus 9 minus 18. Minus 18 plus 18 is 0. So, I'm left with minus 2 minus 3 is minus 1. 2 minus 3 is minus 1. Minus 1 over 3 is minus 4 over 3. So this is 4 over 3. So the area under this curve is 4 over 3. But assuming I solve and I get minus 4 over 3, then that means I'm supposed to have done y2 minus y1. I need to sketch the graph of this in MAT002. Sketch the graph of Px equal x raised to power 4 plus x raised to power 3 minus 6x squared. Now, for you to be able to sketch the graph of something, there's one paramount thing you need to know. Look at it. You need to differentiate. You need to find the derivative, and I'll show you how the derivative is going to help us. Do you understand? Differentiate the PDX is equal to 4s. Don't forget the power will come down, then subtract 1 from the power. 4s raised to power 3 plus 3s squared minus 12x. Don't forget, at the turning point, either at maximum or minimum point, or at local maximum or at local minimum point, the y/dx is always 0. Equate this to 0 first. 4s raised to power 3 plus 3s squared minus 12s equal what? 0. Factorize this, you are left with 4s squared plus 3x minus 12 equal to 0. So when you solve this, s equals 0, s equal to 0, or 4s raised to power 3 plus 3s minus 12 equals 0. Solve the quadratic equation. You need to be able to solve the quadratic equation. I don't want to waste time. I want to use calculator to solve it. You can use formula method to solve this quadratic equation. It doesn't matter. You know you have to show working. Use formula method to solve it. So you have a 4, 3 minus 12. So the first answer is 1.397 something. But I will round off to 1.4. That means if I put 1.4 inside this, I will get 0. Now the second answer is minus 2.14, minus 2.1. That's what I want to do. Now, do you get that? Now, let us determine the maximum and the minimum point. You know, this is a turning point, or we call this stationary point. Differentiate this thing the second time. Look at what we have. The square p over the x square. This one will give me what? 12x squared plus 6x, right? Minus 12. When s is 0, the square p over the x squared will actually be minus 12, which is less than 0, which is a maximum point. Right? It's a maximum point. Now, when s is greater than 0, when s is equal to 1.4, what happened? When s is equal to 1.4, you do the square p over the s square. Anyway, it's here, put 1.4. You can quickly use your calculator on this. You have 12 multiplied by 1.4 all square plus 6 multiplied by 1.4 minus 12. The answer is 19.92. 19.92 is what? Greater than 0. This is a minimum point. They call it local minimum. Now again, when s is minus negative 2.1, this square p over the s square is equal to what? Put s to be negative 2.1, there you have 12 multiplied by 2.1 square or minus 2.1 square minus 6 or plus 6 multiplied by minus 2.1 minus 12. The answer we get is 28.32, which is also greater than 0, which is also a minimum point. So we have two local minimum points. Now look at what I'm now going to do now. You will now check from minus infinity to infinity. Let's say this is where we want to draw the graph. Let's say this is this thing. This is y. This is x. Not drawn to scale, but look at it. I want to sketch this graph here. You know, this is from minus infinity to what? Infinity. So for x. So what do we have? Look at what I'm going to do. I'm going to draw a table. You need to see what I'm doing here. For x, I have f prime of x or the PDS, right? You know, I want to draw the graph of p, then p of s itself. Now look at what I'm going to do. These 3 points have indicated something for me. It means between minus infinity and 2.1, you know, if I start from minus infinity, between minus infinity and then you come, you first get, you know, when you are coming from minus infinity is here, minus infinity, and you come, you are starting from here, you now come, the first place you get to is minus 2.1, right? The second place you get to is 0.0, the third place you get to is 1.4, then to infinity again. Do you understand? Now, you will now tell me what is happening here from between minus infinity and minus 2.1. See, this is a specific point you need to take note. That is why those this stationary point, you need to take note of those points. So between minus infinity and 2.1, what is the YDS? If you check the YDS, pick a number between minus infinity and 2.1. Let's say minus 100. Minus 100 is between minus infinity and minus 2.1. Put minus 100 inside that value, inside the PDS. Put minus 100 here. This one will be minus, just put minus 100 for, press calculator, plus 3s squared minus 12s. When s is minus 100. It is giving you what? A negative value. That means, let me tell you something. That means that between minus, any number you put between minus infinity and minus 2.1, you will get a negative value. Do you understand? So that means the PDS is always negative in this interval. If you start from minus infinity, you must cover from minus infinity to infinity. That is the point. Do you understand? So, but you have to stop at some point. See, this is from minus infinity to infinity. But you have to stop at some point. Where are the points you need to stop? Stationary points. So you will start from minus infinity till you get to the first stationary point. The first stationary point is minus 2.1. So you will now check, is the PDS always positive there or always negative? What does that mean? It means pick any value here, put it inside the PDS and see whether the answer you get will be a plus, a negative, a positive answer or a negative answer. But if you put minus 2.1 is the solution, it will give you 0. But then if you take any number less, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, you get to, as it increases, you get to minus infinity. If you are putting it inside this function, you will be getting a negative value. And what does that mean? Whenever the PDS, whenever the derivative of a function is negative, it means that function is decreasing. It means that function is what? Decreasing. This is how you write it. This one just indicates that it is what? Decreasing. So it is decreasing from, you see, you get my point? It is decreasing like that. Now, when you now start from, I'm done with that one. So minus 2.1, you will now go again. You know, as I was telling you, this is minus 2.1. Stop at the next stationary point. The next stationary point is what? 0, right? From minus 2.1 to 0, if you take any value between minus 2.1 and 0, take any value between minus 2.1 and 0, what do you get? Let's take what is between minus 2.1 and 0? Minus 1 is between minus 2.1 and 0. Put it inside the PDS. Put minus 1 inside the PDS. Calculate when s is minus 1. The answer is 11. That's a positive number. So between minus 1 and 0, you have a positive answer. The PDS is positive. And when the derivative of a function is positive, it means that the function is increasing. You draw it this way. It means that the function is what? Increasing. Do you see the way I'm doing it? Now, from 0 now to the next one, from 0 to the next stationary point. To the next stationary point is 1.4. Between 0 and 1.4, I have 1.4 here. Now, check. Any number between 0 and 1.4, 1 is between 0 and 1.4, or 0.9 is between there. Calculate, put 1, for example, inside this function and see the answer, whether it will give you a positive answer or it will give you a negative answer. Put 1 there, put 1. The answer is minus 5. If you put 1 there, the answer is minus 5. That means it's negative again. Between 0 and 1.4, the PDS is negative. And when the derivative of a function is negative, it means the function is what? Decreasing. Do you understand? It means the function is decreasing. Now, then lastly, there is no more stationary point. I have 1.4. So after 1.4, I go down to what? Infinity. So I will now start again from 1.4 down to infinity. If I start from 1.4 down to infinity, pick any number between 1.4 and infinity. Pick 100, pick 200, pick any value. Actually, I'll put it inside the PDS. You see that the answer you are going to get will be a positive answer. The answer you are going to get will be a positive answer. So, because of that, this one will be positive. It means that this function will increase. Do you get that? So what does that mean? So when s is negative infinity, it is coming down from negative infinity. That means you see how I'll draw this function now. So till you get to minus 2.1. So what is p of x at minus 2.1? You have to get that answer. P of x at minus 2.1. What is p of x? P of x x raised to power 4. Right, plus s raised to power 3 minus 6x squared. Now, at point minus 2.1, if you put minus 2.1, you know that's the answer we got when we find the solution to this. You are supposed to get 0, but put it on p of x. On p of x, put minus 2.1 there. The answer is minus 16.3 approximately, or I'm working with approximate value. Do you understand? So you come again. So that means minus 2.1 is minus 3. So that means the function will come down. This is what it means. So from minus infinity to minus 2.1, the function will come down. So when it gets to minus 16.3 on the y-axis on p of x, this y-axis is the same thing as p of x. This is the s-axis. Do you understand? Because they call this one p of x, so it's the y-axis. Do you understand my point? Now I'm explaining something. So at this place, it will now come up and gets to 0. When it gets to 0, what is p of x? Put 0 here. Is 0 plus 0 minus 0. The answer is 0. So that means it will get to 0. That means it will come up again and get to 0. When it gets to 0, it will come down again till when you get to 1.4. Put 1.4 in, anywhere you see inside this one. Put 1.4 there. Anywhere you see it, put 1.4. So 1.4 raised to power 4 plus 1.4 raised to power 3 minus 6 times 1.4. Calculate 1.4. So the answer is minus 5.2 approximately. So that's when you get to minus 5.2, then it goes up to infinity and it has no end again. Do you understand? So now let me now sketch the graph for you. You can see it's coming from up down. So look at what I'm going to do. This is minus 2.1 that I have ticked. I told you not drawn to scale. Let this place be minus 16.3. You know, this is a negative value. This is 0. Then I have 1.4. Let me draw it well. Let this place be minus 2.1. Let this place be 1.4. Right? Let this place be 1.4. Not drawn to scale. We can use graph to draw it. But then look at it. So that means the function will be coming all the way up. It will be coming down. Do you see? Decreasing from minus infinity. This is from minus. It will be coming down till it get to minus 16.3. It will be coming down, and the value of x at that point is minus 2.1. So it will be coming down till it get to this place, minus 16.3 on this spot. Do you see what I'm trying to do? So it will come down till you get here. It will now go up. So the function will come down when it gets here. That will be the graph, minus 16.3 as I told you. It will now go up. When x is 0, y is 0, it will now, you see, go up, come down again. This is how the function will look like. It will now go up, come down again. You see now, that's another point. It will now come down to minus 5.2. Let this place be like minus 5.2 at 1.4. So now it will now come down again. It will come down till when it gets to minus 5.2, it will, you see, go up again. It will go up. So that means this place that is going up, this place is 1.4. Do you understand? So that's how it will be. Then it goes up forever. Goes up forever. So this function, this is the diagram. This is how to sketch that function. Thank you very much. Please kindly subscribe to this YouTube channel. Thank you.